Now we are ready to align the sample. So here is a simplified sketch to show all the key components of the system again. The X-ray source, the electron neutralizer, the argon ion gun, and the focus of the analyzer lens are all aligned to a single point on this focal plane. So the basic idea about the sample alignment is just to move your sample to that focal plane and put the region of interest to that focal point. To observe the sample during the alignment, a telescope is installed from the back of the system, which is also focused on the same spot. An image could be seen from a monitor which locates right on top of the computer monitors. When the sample is at the focal plane, you will be able to get a sharp image of your sample. And there is a hand-drawn blue cross mark on that screen to show where the X-ray beam will hit on your sample when the sample is at the focal plane. So this telescope will help us to align our sample visually. So starting from the loading position. So first, we will need to manually move the sample to Z position, which is very close to the focal plane. And the Z value for that position could be estimated using this equation highlighted in yellow. For powder sample with negligible thickness, we could just set the sample height to be 0 and type 18.5 millimeter in this Z position box. Then click the Move button. So this will move the sample to that plane very close to the ideal focal plane. Once that motion stopped, you could use the joystick and move the sample in plane. So that will allow you to put the region of interest, usually the center of your sample, under the X-ray beam. Once we obtain a good visual alignment, we will move to the next step to use the XPS measurement to tell where exactly the focal plane is. This procedure is called Auto-Z or automatic Z alignment. To do that, we will need to click the XXI Auto-Z tab on the electronic setting window, and then confirming the system settings for Auto-Z measurement, as shown in this photo. We will use the same X-ray power setting as the measurement and also choose both the electron neutralizer and ion gun neutralizer during this alignment. After confirming setting, just click the Auto-Z button on the upper right corner to start the measurement. Here I have videos to show the close look of the sampled motion during this alignment and also what that looks like from the computer. Once the Auto-Z started, the system will move the sample to a lower position, then slowly move it up while collecting the photoelectron at the same time. The photoelectron count versus Z position curve will be shown in the viewer window. This curve will reach its peak at exact the focal plane. So after the alignment, the software will automatically move the sample to where that peak location is. So usually the Auto-Z peak value is in the order of 10,000 count per second level, but may varies according to the sample's property. Once everything is in place, we will start setting the measurement using the acquisition setting window from the File Submit software, as mentioned earlier. Before adding specific measurement, we will need to confirm several instrumentation settings as highlighted here, including whether using argon ion gun to spot your sample during measurement, whether performing angle resolved XPS by tilting your sample, whether using energy scan mode during the measurement, and whether using the neutralizer during the measurement. For most of the situation, you will just perform the measurement without the argon ion gun sputtering and the sample tilting, but you usually perform the energy scan mode measurement and use the neutralizer for most of the powder sample. After this, you could add measurement by clicking this element table button. As shown here, this will bring you this element table, which will allow you to choose the measurement for specific element. But usually at the very beginning, we do not have a good knowledge about all the elements present in the sample. So before diving into the specific element measurement, we usually need to select this survey scan, or SUR. This will allow you to obtain the XPS measurement across the full bonding energy range and identify all the elements present in your sample. Okay, so add survey scan here. It will show up in this table. After adding this survey scan, you could further modify the measurement parameters on top of the default value. The measurement parameters including the start bonding energy, the total bonding energy range, energy step, and time per step setting. You could also adjust the repeat time and the cycle time to measure the same spectrum multiple times until obtaining the desired data quality. While the path energy here is a very important parameter for photoemission measurement, which defines the resolution of the electronic lens. So here we will just keep the default value. And the suggested value for all the parameters are shown in the table on your right-hand side. So after you set up all the measurement, you just need to go ahead, set up the proper folder and the proper file name. So after that, you just need to click this acquire button, which will start the survey scan. We just set it. And the measurement will show up in this spectral viewer window as shown here. So this is a survey scan for a silver sample, start from 1000 electron volt all the way up to the Fermi surface. Once you obtain and analyze the survey scan from your sample, then you could determine the specific element to be measured with higher energy resolution, which will allow you to understand the chemical states of those elements. This type of measurement is called detailed scan and could be added from the element table as shown here. So we click this element table button. It will bring us to this table again. Next, let's choose specific element. And then in this region list, we usually choose the top from the list. which is the signature line of this element, and usually has the strongest intensity among all the XPS transitions. So here, I add the signature line for all those elements we observed during the survey scan. Okay, after that, we could modify those detailed parameters according to the table on our right-hand side. So here I change all the energy stats from 0.2 to 0.1, which will give us much better energy resolution. And because we already have the survey scan in this table, so we will uncheck that, so which will only allow us to perform the detailed scan in this table. After that, I will modify this repeat number for each element, because those elements may have very different intensity. So I will have longer measurement time or larger repeat number for those elements with weaker intensity. As a result, I will get comparable data quality across all the measurement. And also here, I have a total cycles of 10. So that means I will run those measurement or the whole table 10 times, which will give us much better data quality overall. Once we have everything set it, we just need to click the acquire button. That will start measurement. And the spectrum will show up in this spectral viewer window. So here we have a specific window for each element we measured.